Today we're going to move from predefined functions that are provided by C++ to functions that you write yourself. If you remember predefined functions, there's a bunch of math functions like the power function, POW, or square root, SQRT. There's the rand function that generates random numbers. And we would like to be able to write some functions of our own. So that's what we shall be talking about. So here's the agenda. We're first going to quickly review how we cast ints to doubles and doubles to ints using predefined functions. And then we'll discuss a variety of features of user-defined functions, including how to declare functions, how to define them, how to pass parameters to them, and something called call by value. So as a reminder from last time, there's a static cast function that allows us to cast ints to doubles so that we can do floating point arithmetic. And here you see an example of the use of static cast. We're trying to calculate the average exam score, and we've stored both the total score and the number of scores in int variables. Therefore, in order to get floating point arithmetic, we have to do a static cast of one of the two operands to the division. And in this case, we decide to static cast the numerator to be a double. And you'll notice that the way we know it's a double is that we put the double inside the carets, and we passed in total score as the argument to our function. And here's the what we call function prototype, which is the way it's declared, the function. So static cast is the name of the function right here, and it returns a double, and it takes as a single argument an integer, and we're casting it to a double. Okay, so that was a nice review. Let's now move ahead to writing our own functions, and we'll start by looking at an example user-defined function called area. So we want to define a function that computes the area of a circle. If you remember from geometry, the area of a circle is pi r squared. Hence, we have our little formula here of pi times the radius raised to the second power. And up here, we have defined pi as a double equal to 3.14 and defined it as a constant. So you'll see that as part of our function, we first of all have what we call the function header. And the function header consists of three parts. It consists of the name of the function, which in this case is area. It consists of what we call the return type. In this case, it returns a double. And a parameter list enclosed in parentheses. In this case, there's a single parameter, the radius. And finally, so that's the function header. And then we have what's called the function body that computes the function result and ultimately returns it via a return statement. So you'll see here the return statement. Thus far in the semester, you may have wondered why at the end of main we sometimes have return 0. That's because in main itself is a function. It returns an int, and so we often you'll see return 0 at the end of it because we're returning 0. Now in main we don't have to do it because by default it returns 0 if we do nothing else. But that's not true in any other user-defined function. If we declare it to have a return type, then it must have a return statement. Now you'll notice up here that we also declared the function, and this is called a function declaration or prototype, as opposed to down here where it's called a function definition. What's the difference, you might add? Glad you asked. So function definition includes both the function header plus the function body, whereas the function declaration consists of only the function header, and then we terminate it with a semicolon. You'll often hear us refer to this function header as a function declaration or a function prototype. You'll also notice I put the function prototype before main and the function definition after main. Why did I do that? Well, down here in main, I actually called my function area. I was printing out the value it returned. And you'll notice that my call to area precedes the actual function definition. So if I did not have my function declaration up here, the C++ compiler would complain, because before you use a function, you have to declare it. So here's its use, up here is its declaration. And you might ask, well, could I just put the function definition before main? The answer is yes. It's a style thing. In this course, we're going to encourage you to put your function declarations before main and your function definitions after main. It just tends to look better that way, because normally when someone looks at your program, the first thing they want to do is look at main, and so it helps if main is near the top of the file. And if you have all your function definitions before main, main will be buried pretty deep in your program, and we'd prefer not to have it that way. Okay, so that gives you some idea of functions, declaring them, and then defining them down here. And right here, this was a simple program where we were using the function. We simply declared a double called R, asked the user for the radius of a circle, read it in, and finally printed out the area of the circle, and did that by calling the area function. Okay, so the rest of this is going to be a bit of a review, so we'll go somewhat quickly. So again, a user-defined function has two parts. It has the function declaration, which consists of a function name, a return type, and some parameters. And that's different from a function definition, because a function definition is the function declaration plus the statements that make up the function body. So the function definition is the full definition of the function, including the function body. Okay? So a few things more now to discuss about function declarations. Here's a couple more, or a couple examples. So here we have our function area. Here's one. If we were declaring a double, we could, or a POW function, we could have it take base and an exponent, so two parameters, and you'll notice that it is a comma separated list of variables, and our POW would return a double. And in general, a function declaration starts with a return type, followed by the function name, and then a parameter list in parentheses. And again, that parameter list may be a comma-separated list of variable declarations. And again, a function must be declared before it can be called, so we'll often place the function declaration before main. So here's just a simple demo. Let's say I wanted to write a function prototype for a function named twice, which has an int parameter and returns an int. Well, that gives me the three components I needed for declaring a function prototype. Remember, I need a return type, a function name, and then a parameter list, like that, and then a semicolon. Well, my return type, it says it returns an int. Therefore, the return type is an int. It says for a function named twice. Therefore, the function is named twice. And it says it has an int parameter. So in this case, my parameter list consists of a single parameter, which is an int. And it's optional as to whether I name it. We frequently do, so I just might name it x. But it is not necessary. This would be a perfectly fine function prototype right here. Naming it for documentation purposes, so someone looking at your function prototype might have an idea what the different parameters mean is often even better. Okay, let's move on now to some function definitions and parts of a function definition. So again, the function definition is both the function prototype or header followed by the function body. And you'll see the function body is always enclosed in curly braces, and this is the general syntax. Again, curly braces, the statements for the function body, and typically at the end we'll have a return statement that returns an expression, and the type of this expression, or the type of value computed by the expression, must match the return type. And stylistically, the function definition normally appears after main. It's okay if it goes before main, but we prefer to place it after main for stylistic reasons. And just again, some more both style and necessary things. So typically we place our variable declarations at the top of our function. Just like functions must be declared before we use them, variables must be declared before we use them. So we typically put them at the top. Here you can see we have one additional variable. We often call them local variables because they can be seen only within the function. They cannot be seen outside the function. So here I've defined the int variable result, and I am summing the values of 3 exams and returning their average. And I'm fine here with integer arithmetic. Okay, so I simply, after computing result, my return statement returns it. It's important also to know that you can have multiple return statements in a function. It does not just have to go at the end of the function. And the return statement can allow you to exit a function early if you know the result before you've reached the end of the function. So here I've defined an absolute value function. The absolute value of a number is its positive value. So for example, -3, the absolute value of -3 is 3. The absolute value of 10 is 10. So the absolute value of a positive number is always just returns that number. And that's what we have right here. If the parameter, which is input, is greater than 0, we simply return it. But if the number is a negative number, then we invert it. We return its positive form, which we can do by simply negating it. So if the number is -3 and we return -3, that's a 3. So each of the two branches of the if statement had a return in this case because in each case that arm computed the correct result and then was ready to return it. And you've already seen this. It is permissible to have a function call in the body of another function. So here I use the predefined function pal in my calculation of the area of a circle. So here's a little exercise which I'm going to perform for you. We want to write a function is senior. So oftentimes restaurants will give a senior citizens discount, or a movie theater might give a matinee rate for a senior. So we're going to have this function is senior that's going to return true if the person's age is greater than or equal to 65 and false otherwise. So we'll start out by writing the function header, and we're already told that the name of the function is senior, and we're told that it receives an integer parameter, which from my description you should infer is the age of the person, and it returns true if the parameter's value is greater or equal to 65 and false otherwise. But the returns true is a tip-off that we're returning a bool. So that's our function header, and now we need to write the function body. Remember, the function body is always enclosed in curly braces. So we're going to return true if the parameter's value is greater than or equal to 65. So we can say if age is greater than or equal to 65, we shall return true, else we shall return false. So that gives us the definition. Now, you can write this function much more simply, because this expression right here, age greater than or equal to 65, it returns true if the age is greater than or equal to 65, and it evaluates to false if age is less than 65. So I could really write this function much more simply by just saying return age greater than or equal to 65. And it works because this expression is true if age is greater than or equal to 65, and it's false if age is less than 65. And just again to review, we think it's good form in this course to put our function declarations before main and our function definitions after main, but in all instances, a function call must be preceded by either the function's declaration or the function's definition. We can't call a function before the compiler has seen some declaration of it. So here you see our good form. We've put the function prototype before main, the definition after main. And you'll notice here in the prototype I did not have to provide names for the parameters. In the function definition I must, because now I'm declaring the names of the parameters that I will use in my function body. But up here, all the C++ compiler really cares about is the types of the parameters. Nonetheless, you'll often see us name the parameters in the function prototype because it's good for someone reading your program. It helps them know what the different parameters mean. Here, wouldn't know that the first double is really for the length of the rectangle and the second double is for the width. But if I actually had written, say, length and width, then someone would have a good idea about what those two parameters mean. Okay? And you cannot define a function in the body of another function. So for example, if you try to place a function definition inside main, it will cause a compiler error. Similarly, if I just had tried to declare the function, it would also be no good. It would have given me a compiler error. So function declarations and function definitions must go outside any other function. They cannot be nested. So we're going to wrap up our discussion of functions with parameter passing and call by value. You've basically now seen how to write a function, and we want to talk about now how you call a function. And we're going to make a distinction between what we call arguments and parameters. As much as possible, I'm going to reserve the term arguments to be the values or variables used in a function call. So here I'm calling area with a radius of 5. Here I'm calling exam average with midterm 1, midterm 2, and final. So when I call a function, the values or variables I pass, I'll refer to them as arguments. When you hear me talk about parameters, I'm typically talking about the variables in a function declaration. So here's two different declarations of the functions that I called above, and here radius is the parameter for area, And here, exam 1, exam 2, and exam 3 are the 3 parameters for exam area. And the reason for being pedantic like this is it'll make it easier when you hear me talk about arguments. You'll think, oh, he means we're talking about calling a function. And when Dr. van der Zanden talks about parameters, he's talking about the function declaration or the function definition. Now, something that's very important to get into your heads is that argument names do not have to match parameter names. In fact, it would probably be good if you gave them different names. So notice here, when I called exam average, I used midterm 1, midterm 2, and final. But when I declared them down here as parameters, it was as exam 1, exam 2, and exam 3. The reason the argument names don't have to match the parameter names is you declare a function once in your program. You're allowed to use it in as many different parts of the code as you want. In a large program, like if you were writing programs for Amazon or for eBay or Facebook, you might call this function from 1,000 different places in your program. And it would be very difficult to ensure that all 1,000 calls always had their argument names match the parameter names that was used in the declaration. So very importantly, you do not have to have the argument names match the parameter names. Now, it is necessary that the data types for your parameters and arguments match. So when I declare that the first parameter, in this case the only parameter to area, is a double, then by gosh, when I call area, the argument needs to be a double. And you can see that R is in fact declared as a double. It's okay if your functions have multiple parameters. So here we have length and width, and when we call the function, the arguments are matched to the parameters in the order in which the arguments occur. So in this case, the L comes first, and hence it's matched to length, and the W comes second and is matched to width. And again, the types must match. If for some reason I had declared width to be an int, then down here it would be necessary that W be declared as an int as well, so that W's type would match the type of width. Okay, we've already mentioned how prototypes may omit parameter names, but in the function definition you have to provide the parameter names. The last thing we're going to talk about is this concept of call by value. And what call by value means is that the values of the arguments are copied into the parameters. So you've already seen this, that the first argument in the argument list is passed to the first variable in the parameter list. The second argument in the argument list is passed to the second parameter in the parameter list, and so on. And the values are copied into these parameters. If you change the parameter, the argument will not change. So again, it's important to note that the parameters are different from the arguments, and they're stored in a different place in memory. And when we call the function, the arguments are copied into the parameters, but then when we change the parameters, it doesn't change the value of the arguments. So here we have a program that's simply computing the area of a square, actually of a rectangle, and it has two variables, L and W, which are 2 and 3, and we're now calling area with these two arguments. And when we do that, the value of L gets copied into length, and the value of W, which is 3, gets copied into width. Now notice that in the function, we are incrementing length and width. So that will increment length to 3 and width to 4. And when we print out the length and width here, it will print out that length is 3 and width is 4. And now we'll return 3 times 4, which is 12. And it's going to be very confusing now to the user if we were to look at what is the output of this program. Let's add one more table here. If we were to look at, okay, what is the output of our program? Okay, it starts here, okay, and it would be length equals 3 and width equals 4. Okay, now we return 3 times 4, and we'll here print out the area of that square is 12, because that's what was returned by the function. And now here we'll print out L equals and W equals, and you'll see that their values did not change. They're still 2 and 3. So we'll print out L is equal to 2 and W is equal to 3. So call by value, that way of passing parameters, copies the values of the arguments into the parameters, and when the values of the parameters change, that doesn't change the arguments. Now, in this course, some of you are going to think, okay, perhaps if I just had written length equals 2 and width equals 3, you're going to say, ah, now length has the same name as this length, and width has the same name as this width, and you're thinking, surely now, with these names being length and width, that when I modify the values down here of length and width, it must modify these arguments in the main procedure. And the answer is no, it doesn't, because the length and the width here are completely different and in different parts of memory than the length and width in main. So no matter what you do when you're using call by value, it's impossible. It is impossible to change the value of a parameter and have it affect the value of an argument in what we call the calling function.